Okay, thank you. Hello everybody. Before I start, could you please confirm that I can be heard properly and that I'm sharing the screen where the Acoubat by Cypher shortcut is in the middle of the desktop? Okay. Okay, thank you. Yes, so I think I'm ready to start now showing Acoubat by Cypher, which is a software that analyzes and designs the sound insulation and conditioning of buildings. But today is not going to be my typical software presentation. Today I'm going to do something different. Instead of starting from the Model tab, which is the input part, I'm going to start directly with the Analysis tab, which is the output part. So, in seconds, I'm going to show you the analysis tools and reports that this program is able to produce. Are you ready? I hope you are, because now I'm going to show you the results for this big building, which is a hotel. And I'm going to press here in the Analyze button. And as you see, I get the first output, which is the analysis summary. What is this? This is a very interesting tool from my point of view because you get a lot of information, very visual. In fact, it includes this dynamic histogram. So you get an idea of how many spaces meet the requirements and with which values. And in case of if some spaces don't meet the requirements, how far or near from the value they are. I'm going to show you with this example. As you can see here in blue, I have selected the insulation against outdoor noise, and for this parameter, 32 spaces meet the requirements. The limit is 30 decibels, and as you see here, the values I have for the different spaces are 37, 38 and 39. If I prefer to see it as a table, I can click here and I can see the values, how many spaces I have with those values, and what is the difference between the required value and the value I have. In this case, it's positive because the value is bigger than the limit. What happens in other parameters for other parameters? For example, for the insulation against airborne noise, not everything meets the requirements. As you can see, there are 401 spaces that meet the requirements, but 64 that don't. If you see here, there are green bars with these values that meet the requirements, but there are other red bars. These are all the cases that don't meet the requirements. If I see in the table tab, I can check what is the difference, how many decibels are difference of decibels between the required value and the value the program calculates for this space. So that's the spaces that requires improvement in terms of acoustic values. This is the result for the protected spaces. I can search, for example, for the habitable spaces. In this case, for example, for the habitable spaces, all the spaces meet the requirements. For the common area, there are some that meet the requirements and some that don't. These are the results for the stairs, technical room, restaurant, and noise room. Later on, I'll explain you why I have this type of emission spaces. You can set your own, okay? We'll do that in the second part of the presentation. Now I'm going to show you only the results, okay? Okay, so one thing that I think is interesting, as you can see, I have also the possibility to search depending on the type of receiver space. One thing I want to say is that this analysis summary can be consulted anytime. You can press in this button and you will get the window with the new results. Okay? Okay, but you might be asking, are there other ways of seeing the results of the different calculations? Yes, of course there are other ways, because what I have shown you before was the final value, but I'm sure you want to know the detail of the calculation. Okay, this is very easy to do, very intuitive. That's what we have tried to do, a user-friendly program. So as you see here in this window, there's a built-in tree. You can search for starters from use units or for spaces without an assigned use unit. In this hotel, the rooms, including the bedroom, corridor, and bathroom, are use units, and the rest, like this, and room, bathroom, and balcony. The corridor is included in the room, and there's other type of spaces that are not in use units. For example, the pressure set room, the technical rooms, offices, the toilets, the common toilets, the hall, stairs, etc. So let's start, for example, with the results for a room. If I click here and then in a certain room, I'm going to choose this one because it has a red symbol, so it means that something is not right. I'll show you how the program shows us that. If you see, the moment I click on the space, I can see in orange the location of the space with all the different surfaces it has. Okay? Remember that what we are seeing now is the receiver. Okay, so we see in orange the receiver space. What kind of calculations I'm doing for this space? You can see here that there are 3 checks. The insulation against outdoor noise, the insulation against airborne noise between rooms, and the impact sound pressure level. Let's go one by one, shall we? So, for example, for the insulation against outdoor noise, I can see that in orange I have my space, and then external, because the other space is the exterior. So here I have the final result of 37, and as this is greater than 30, that is the limit, I have a green tick that says that it's verified. I can click here in results and get the report for the calculation. This is in different formats. I can see it as a table, as you see in 1/3 band Dave's table. I can see it as a graph with all the different paths. And I'm sure you want more information, okay? Because that's the overall information. How can I search for it with more detail? It's as easy as clicking here, and this will expand, and in this case it will show me the 3 walls that are involved in the calculation. When I click here, I can see in blue, turquoise, actually, the wall involved. Okay, so that's the wall 1, wall 2, and wall 4. In this case, for example, for the wall 1, there's a direct element, which is the facade, and then the laterals, that are the flanks, that are going to be represented in different colors. Okay, so you see the different paths that the sound is transmitted by. There's another possibility, for example, for the wall 2, this has a direct element, the facade, and also an opening, the window we see here. And of course, there are lateral transmissions too. If we click here, you can see exactly the different paths. And of course, if we click in the result button, we get the representation of the results, including the equation that we have used. Okay, the different frequencies. And then this other, because this is an exterior space, an exterior stair, that's why it's still a wall, and then the different flanks. So that's about the external noise. But what about the insulation against airborne noise? In this case, you can see all the checks that we have made for this space. And in order to make easier to locate the different spaces, you can see that in orange there is the space we are analyzing now, the receiver, and in yellow is the emitter, the source of the sound. So, for example, if I click here, now I can see that it's the next room. The F1 is for floor 1, room 102 is the next room. And, well, in this case, we have this wall in common. So there's a direct transmission of the sound, and then this lateral, these other flanks that are generating, of course, or transmitting the sound. And a very interesting part in this program is that it's also able to consider an indirect sound, in other words, considering the transmission through another space that is not one of the spaces that we are analyzing. So, for example, between the room F1, room 101, and the room 102, there's a third space, which is the corridor. As you can see here, I'm going to rotate it a little so you get an idea of what I mean. This space is communicating also these two spaces. So this is included, the calculation of this is also included in this, for this consideration. So here we have this, okay? There's also the possibility, this is the example when to the one room with the next room. But for example, if there's another room like this one, these rooms don't have any wall in common, any wall or partition, I mean, not a floor slab or anything, but they have, there's some transmitting between them because there's the corridor communicates them. So, as you see here, that's included in the calculus. Okay, and you can see with much detail everything that is included in, including the door and the different partitions. Okay, so that's quite detailed, I think. Well, that's about the, well, of course, this is the between the spaces in the same floor, but it can consider the rooms of other floors. Oh, sorry, this is F1 again. I have to see F2, floor 2. That's the name I gave to the different spaces. I can see here the sound calculation between the room that is above my room and then other rooms that are in the other floor and only share an edge. So that's another, in this case, we have only lateral or diagonal transmissions. Better, okay, not lateral, diagonal transmissions. And that's another, and the same with the other room that is in this position. So there's always a 3D, I mean, everything that I see in this window, as I click on the element, I get that represented in the 3D view. So it's very easy to know what I'm talking about and don't get lost, okay? So that's about the insulation against airborne noise. Let's talk now about the impact sound pressure level. In this case, for example, I can see that I'm checking that for the room, for the next room, or the room that has this wall in common, this partition. And here I can see the different paths, lateral 1 and lateral 2, and of course I can see with detail all the calculation that the programs have done, okay? This is the 1 by 1, or I can get the final values, okay? Of course, the room, I can see the room that is above mine, and also these other rooms that I saw before that also share an edge. Okay, so is the program able to analyze more parameters? Of course. In this case, for the room, that's the 3 parameters I wanted to check. But for example, for the lobby, I wanted to, the lobby, well, let's move a little bit this. The lobby is located here, as you can see. And what have I checked for this? The area of reverberation. In this case, it has to be in greater than 0.7 and is greater square meters and is greater, so it says verified. And here I can see the formula used and the different detail of the values that I have obtained. Okay. For example, there are other parameters that I would check that are related to the reverberation. For example, in another room, which is this is the lobby. So, for example, in the in the dining, for example, because I have quite a big restaurant. In this, instead of the area of absorption, that what I showed you before, in this case I'm checking the reverberation time. In this case it has to be greater than 0.9 second and is less than 0.9 second, and as it's greater than the value, it says that it's not verified, and the program tells us how much or the difference between the required value and the real value. So here I have all the detail of the calculation, so I can get the right decision and of course improve it in this case. Okay. What else? Well, this is the way of seeing it one by one, okay? But of course there are other ways of seeing the results in a more compact way, or a lot of values at the same time. How can I do that? Well, I have shown you the analysis part. Now I'm going to show you the reports part. There's this button, which is results report, which allows us to get different types of reports. For example, I could get the summarized report for all the building, and I can check room by room. For example, for this first room I showed you before, all the checks that I have made and the final values, and if the different parameters are verified or not. This is the format I have. I can export this document in different formats. Here you can see you can export it as PDF, docx, text format, HTML, or RTF, or you can print it directly, whatever you prefer. There's also more possibilities. For example, you could print only the spaces that fail, so that can be interesting when you are still trying to improve the building and don't want to that's not the definite state of the building. You're in the process of improving it, so you can get the report for the rooms that don't meet the requirements in some level, for some magnitudes at least, and check for it. One thing, talking about formats, I show you the different ways of exporting the reports. I want to tell you that in the case of these the results of each space, it is possible not only to export in these formats, but also in XLS format. So you can export this in order to use it in Microsoft Excel later on. Okay, that's quite useful, I think. Okay, so what else? Another interesting report, or two interesting reports, are the material property report and the material schedule report. In this case, the material property report is a summary of all the constructive elements that I have used in this building, with the definition of the acoustic values in 1/3 octave frequency bands. So you can see here this, which is very important. It says the source of the data, if it's measured in the laboratory, like in this case, or other situation in case you have introduced it manually, as I show you later. Okay. And then the last report is the material schedule. which is in the model part we have used different references of materials, and here the program tell us how many square meters of each material we have used and the properties of the materials in terms of the name of the product, the class, origin, mass and thickness. I think the two material reports are complementary. So with all of this you have all the information you need in terms of materials. Okay, now that I have shown you the analysis tools and reports, I think we are ready to go to the second step, which is the setting of the acoustic analysis indices and limits. Because I guess some of you must be now wondering, why is the program checking these particular parameters for this space? And why with this value? Is that something fixed? Or is something I can change? I have good news. This is something you can change. This program is very flexible, and the user can set a lot of values using their own criteria. And now I will show you how to do that, okay? A very important part of this program is the General Parameters button. Here you can set, let's start from the left. First of all, the design options. I'm going to move this to the left so you can see better what I'm talking about, okay? Here in design options, the user can set what magnitude they want to use. So, the reason I'm seeing here, for example, here, for the, okay, in this part, I'm seeing here for the, okay, I think it's better, yeah, I prefer like this. In the isolation against airborne noise, why I'm seeing the NTW? Because that's what I have set here. Sorry. I have seen this, but why am I checking? Sorry. Let me repeat this. I can see a lot of values, but the value that I'm using is this in this column. Here the D2MNT ITR, or for example, for the acoustic index for airborne sound insulation between rooms, I'm using the standardized A-weighted level difference. This is what I'm comparing. Why? Because that's what I have checked here. I could have used another index. The same, for example, for this. This is exactly what I'm checking, that is this column, is because that's what I have set here. I could change it with my own, what I prefer, or probably depending on the norm or the standard I want to use. Okay, here you can see that for the impact pressure level, I'm using the standardized global impact sound pressure level, and that's because this is what I have selected here. Okay, I could select another parameter. And the same for the magnitude used for equipment noise level. There are many options and different options for the calculation of the absorption of the meter space. In case you have doubts about this is explained in the, let's cancel this 1 second, in the website of the program. Here is with more detail the meaning of every magnitude, okay? Okay, let's go back here. In the general parameters, I just explained the part of the design options, but these 3 buttons are very important too. First of all, the program is prepared to calculate the sound produced by equipment, and here you can define it. Okay. Another thing is very important in this case is the type of spaces for the acoustic analysis. In this case, for example, the room, I said that it was protected, and it implied, if I edit here, it implies that acts as a receiving space from outdoor sound, and that the limit I want to check is of 30 decibels. That's why I have this value. If in my country I need to use another value, I can tell it, of course. And if I change the name of the reference, I can keep it in my computer and use it for another file. Okay, so this limit is used because I said it. Okay, and another question: why I'm checking the insulation against airborne noise with these other rules? This is because in interaction between space types, there's this very interesting window in which I'm saying that when the receiver is protected, for example, and the source of the sound is a protected space, for example, another room, I want to check the standardized weighted level difference of 50 decibels and the standardized global impact sound pressure level of 65. So that's why I'm using this limit 65 here and 50 here. I can change the values depending on the type of source. For example, for habitable I have the same common area, but for example with the stairs, I'm not checking the impact sound insulation, only the airborne sound insulation between rooms, for example, okay? So that's something that you can set. Now I guess now you understand why I was seeing those type of spaces in the analysis summary, for example. This is something that I can set, and it's very easy to create new type of spaces with my own checks, okay, with my own requirements. And if you create your own criteria, you can export it to the library and use it in other files, okay? In case you are in one of these countries, you are lucky because the standard is directly implemented. But if you don't, it's not a big deal. It's very easy to create the properties and use it in all the files you want. You can use it in your own computer or share it with your coworkers. Okay, so it's really, really easy to do it. Well, I think now that we have covered the analysis tools and reports and the setting of the acoustic analysis indices and limits, let's go to the acoustic database, okay? Here is in the model tab, and it's a very, very important part of the program because it's the acoustic database. Only by installing the program, by default, you're going to get over 2,400 products. These values have been measured in laboratory, as you can see, and you can use them in your projects. This, as you can see, there are many, well, there's in different, depending on the type of element, you can see, for example, space separating elements, and you can search for concrete walls and slabs, floor constructions, load-bearing walls and facades, facade constructions, roof constructions, interior walls, all the type of constructive elements you need in a building. Here I'm searching by visual inspection, but there are many ways of looking for materials. As you can see, there are direct products and also manufactured products of different brands. I could search here, as you see here, I could search, for example, for a brand I know. For example, I know Rockwood. If I write this brand, I'm going to see all the materials that we have with this brand, for example. There are other ways of searching for elements. This is the advanced search. Here, you can see in advanced search, if you click here, you could search, for example, what materials have a mass in a certain interval of values. You can set a minimum value and, for example, between 5 and 50, for instance, just an example, okay? Please show me materials with these range of values, or combining more than one parameter, okay? And the program will look for you for that. Another interesting tool is that you can compare different materials. For example, let's see, yes, this for example, okay, that I have this material has two possibilities in terms of thickness. I can see the values for the material, for this first material, and if I click here and then the other one, I'm going to see the two materials, the values compared in this graph. The program is going to tell me which is the product 1 and the product 2, so I don't get confused. And well, it can help me to choose the right material. Okay, so that too can be interesting. Now, one thing that I guess more than one of you is asking themselves or wondering, what happens if I want to use a material that is not included in this massive database? It's possible that you want to use another material. How can I use it? Yes, you can. You can add here more materials, and it's very easy. The way of doing this is that you have to click on one, preferably one that is of the same, that is similar. So for example, imagine you want to insert another concrete of another thickness. For example, I click the one existing material and then click here in create a new product based on the data of this product. I click here and now everything is editable. So I can change the product ID, the name, the mass, the thickness, and all these values. I can change it one by one, or I can copy and paste, for example, from a spreadsheet. Okay? There's also a connection between Acoustics and this program, so it's also a possibility, okay? And well, you can change the value of this parameter, this and alpha, and then say how have you obtained this. If it's an unjustified value, you don't have the justification. If it's an estimated value based on on-site measurements, or if are values measured in the laboratory in case you have measured some materials. And it's as easy as accept. Let's I'm going to write new so I know it's my material. I accept, and here I have another material that I can use. It will be included in user-defined product, so I don't get confused, and I know that is something I made myself, not the CSTB. Okay, so well, one interesting thing is that here I have shown you the total Acoubat library, but when you are giving properties to the different materials used in the model, when you click in the, for example, in base element for facades, the program doesn't show me everything that it can be inserted. It shows me specifically elements that could be used as facades. Okay, so it's really easier to do it like that. The same goes with, for example, air inlets. If I come here, I can see directly air inlets of the HVAC installation or the ones that are included in Windows. Okay, so I think more or less I have shown you the main tools of the program. So I think now we're ready to do a step-by-step example. Let's do a little example so we make sure that everybody understands the way this program works, okay? And you will see how easy it is. Let's start a new file from the beginning. So here, from Acoubat, by side, from this icon, I'm going to say new, and I'm going to give it a name. It's going to be a restaurant. I'm going to click here. I'm going to save it in a special folder. I have this. Let's accept it. Yeah, I already did one for testing, of course. And I want to link to a project in this case, the one I have with an acoustic study for the restaurant. So I'm going to insert this analytical model of the restaurant. So in a question of seconds, I have here my restaurant. As you see, when I start, I get a lot of exclamation marks. This means that these elements have to be defined. I have read the type of element, but they don't have acoustic properties. So how can I do this? It's really easy. My advice is to start always from left to right, okay? In the presentation I started from the analysis because I wanted to show you the results. But when we are doing a real example, we start from the left to the right. Okay, so we start here in general parameters. When we start from scratch, everything is empty. I could create the type of spaces and the interaction. I could define, well, I don't have any spaces yet, but if I could create my own type of spaces and then define interaction between them. I could use one of these by default countries, or in this case, I'm going to use my own selection. I have one that is in English, and in which I have the type of spaces that I showed you before, okay? I have protected spaces, habitable, a common area, different properties, for example, for a restaurant. So this is exactly what I want to do. Okay? So here, for example, to this restaurant, I want to check the reverberation time. Okay, let's accept these values. Now I can see the interaction I have. Okay, so for example, this is going to be from the restaurant. I want to check. Okay, these are the restaurant doesn't have a interaction with other species, but for example, a protected spaces will have a check with the restaurant. So depending on who is the receiver, who is the emitter, there will be a different interaction between them. Okay, we'll understand it later. Hopefully. Okay, let's accept. And now that this is done, it's very easy to define the properties of the spaces. Okay, because for example, the toilet, I have two toilets, but the two have the same type. So I can give I'll give the properties at the same time. So the toilet are going to be defined. And what type of space is going to be for the acoustic analysis? It's going to be, depending on how, for example, I could say habitable, not as with so many checks as a protected, maybe protected is too much. That could be, say, for a room, for example. For a toilet, habitable is okay. And then what will I do for the dining room? I'm going to say that is defined, and I'm going to use restaurant. I have a very precise type of space for this. And what about the kitchen? The kitchen could be defined as a noise room. Let's do that. As you see, the exclamation mark has disappeared. Now what do I have to do? I have to give properties to the facades. In this case, I have only one type of wall. So in one step, I'm going to give properties to all the exterior wall. It's very easy. I just have to click here in base element, and the program lets me choose from all the Acoustic Database or the CSTB, and I could choose any option I want. For example, I could say that I want this solid bricks solution. Okay, I with these properties. Let's accept. It's only an example, okay? And I could use an internal aligning. For example, if I click here, that's interesting, okay? The program is intelligent in terms of that it knows if some elements are compatible between them or not. So, for example, with the base element that I have used, it knows that these two thermal aligning could not be okay, and this could be okay. It's compatible. So I have the certainty that this is compatible. I accept, and here I have this wall with these two this composition, okay, of a solid brick and then the insulation. Let's go to the partition. For example, for the partition, I'm going to do something very simple, okay? I'm going to choose this brick, the first brick. I get the option. This is okay for this example, and I don't have basement walls, so no need to do this. Let's go to the script. In this case, let's see what I have here. I could choose, for example, this type, and then for the roof, if I click here in base element, I get, for example, let's choose terracotta tiles roofs of this brand, for example. Okay, that's for now it's enough. And now the openings. For example, the doors, I have two types of doors. I see here I have used these doors, defined these doors for the interior. I'm going to click here and choose interior doors. So imagine this could be okay for starting, okay? And then the double door, that's the exterior door. So here I'm going to choose this exterior door, okay? And well, the windows, I have two types of windows. Okay, so for example here I could use, what's the double? Well, I could use this double glazing window, this for example, and this simple window. By the way, one thing that I get sometimes some people have asked is if we have windows with seals, and yes we do. If we click here, you can see here that we have doors and windows with seals. Okay, so for example I could choose this. Okay, so I didn't want to forget to say this, okay, that there's this option. Okay, and this is finished. I don't have any more things here to do. And then there's one use unit, that is the restaurant, that includes all the spaces. Before I change it up, I'm going to press here in editing errors. So the program is going to tell me if I have any editing error. It says the model is correct, accept, perfect. So I'm ready to go to the next tab. Here, if I go to Analysis, I can press in Analyze, and as I showed you before, I get the dynamic histogram. Now it's much easier to see it because it's a very simple example of 3 spaces, but it's quite interesting anyway. In this case, the insulation against airborne noise for the habitable spaces are not met. And the same happens with the impact sound pressure level. There are many things that could be improved. So how could I analyze this? For example, I could see the type of problems I have. For example, here in the dining room, I can see that the reverberation time is not is greater than for a lot of the seconds. The limit is 0.9 seconds and the value is 9.30. So it's clear that I have to improve the conditions of here. And I'll show you, for example, one option could be to put an element between the roof and the space. There are many ways of doing this. I'll show you one of the ways. Here, okay, I can see that this is the space is the dining room, and that's the reason I'm having this check is because that's what I have set here in sound conditioning. Okay, how can I improve the properties of the roof? Here I can come to the model, then in the dining room here I have these floor slabs, I have the screed, and I have the roof. And of course, it's the roof what it's better idea to improve. I can click here and give include a button lining. If I press here in change selection, I can see that there are some subfloor covering. For example, I could use something like this, for example. Okay, there are many options of suspended ceiling. Let's choose, for example, this one. This is only an, okay, it could be an idea, okay? I can see here the improvement that I'm going to get in terms of acoustic R, and also the absorption, area of absorption. So if I accept here, and I always check the editing errors just in case, I can come back to Analysis tab and pressing Analyze, and this is perfect now, okay? So that could be a good solution for this case. What else? For example, what could I do? In the toilet, there's a problem with the impact sound pressure level. It is in grade 3 decibels greater than the limit. So there should a good idea could be to put a better better element in the above the screen. How could I do this? Here, I'm going to do it I could do it here, and then insert a top lining. Here, I could put a floating screen, for example, of this. This could be a good idea. I can press in editing errors, and if I come to analysis and analyze, I can see that this is totally solved, okay? There are many options, okay, with materials, no materials, etc. Just an example. And then, for example, here, the dining room, the insulation against airborne noise with the dining room is not right. I could expand this and see what more detail all the different walls involved. In this case, for example, here I can look at these values, and for example, I could say that in this case the worst value is this one, and I can see here that there's a direct element, but there's also an opening. Look at this. This is not a very good value for a door. So maybe I could improve the door, and this kind of thing is what the program is meant for, okay? In order to analyze and take the right decisions and improve, etc. I think, I'm going to leave it like that, because I think I covered everything I wanted for today. What I want now is that I hope that you are curious about this program and you want to use it and try it and start playing with it and take a look. And of course, if you want a deep dive of this program, please contact us and we can schedule it, okay? But for now, I think for this seminar is enough. Thank you very much for your attention. And now is the moment for the questions and answers.